Today, we're going to look at how to solve probability questions. We're going to use either a tree diagram, an outcome table, an organized list, or we're going to use multiplication. So let's start with the tree diagram and a fairly common problem. We need to find the probability of spinning red and rolling an even number. The first thing we need to do is list all the different outcomes on one event. So our first event would be rolling our die. Once I've rolled it, I have the possibility of getting 1 or a 2 or a 3 or a 4 or a 5 or a 6. Once I've rolled those different numbers, I need to account for what the spin will be after the roll. So if I've rolled a 1, I can have a red, a green, a blue, or a yellow. That means I have 1 red, a 1 in green, a 1 in blue, a 1 in yellow, a 2 in red, a 2 in green, a 2 in blue, a 2 in yellow, and so on. So now that we have all the different possible combinations listed through using our tree, we're going to go back to the question. I'm only interested in even numbers. We need to look at the 2, the 4, and the 6. And I'm only interested in red. 1, 2, 3. So using that tree, I can see that there are 3 possible outcomes where I would get red with even. Now I need to figure out what the denominator is. And the denominator is going to be the total outcomes. 4, 8, 12, 16, 20. There are 24 possible combinations that could happen. So there's the first demonstration of how to solve that problem. Now let's look at an outcome table. An outcome table is the same information, but for some kids looks a little more organized. So we're going to start by creating a table with an X and a Y. Along one side, we're going to list all the colors. Along the other side, we're going to list all the numbers possible in our roll. So I've got red, green, blue, and yellow, matrixed across 1, 2, 3, 4, 5, and 6. So we're going to use this information, and I know that this part stands for red 1, and this part stands for red 2, and so on until I've filled up my entire table. Now using that, I'm looking for reds and evens. Is there any point in looking down those 3 rows? None of them are red, so I'm not even going to consider that information. I'm only going to be looking down the red column. So I'm looking for red and 2, red and 4, red and 6. That still gives me 3 possibles, and altogether, all the different combinations was still 24. One more. We're going to look at the organized list. To me, the organized list looks incredibly similar to both the tree and the table, only without the added benefit of being organized. You need to remember to list every single item. So red with 1, red with 2, red with 3, and so on. Once you have it all listed, it looks like a grocery list. It'll still work, but you need to make sure you haven't missed anything. The nice thing about the table is that you can see if there's an empty spot, and you know if you've missed something. Our last way, we're going to look at how are we going to multiply. We need to find the chance of each event occurring and multiply those different probabilities. So the chance of getting a red is 1/4. I have 1/4 of the circle filled up with red, so I'm going to use 1/4. The chance of rolling an even number is 3/6. I could also use 1/2, but we'll stick with 3/6 for now. Then I set it up as a times table. 1 over 4 times 3 over 6. 1 times 3 is 3. 4 times 6 is 24. And our last step is to reduce. So even though I haven't shown the reduction in the previous examples, it is still an expectation at this grade level. So this method is also great when you have more than 2 events. For example, if we needed to roll a 2, then we needed to roll again and roll a 5, and finally spin red, how would we set that up? A tree diagram would become cumbersome because it would have so many branches it would be hard to read. To be able to do an outcome table, it would need to be 3-dimensional, which is not helpful. So we're going to rely strictly on multiplication. The chances of rolling a 2 are 1 in 6. The chances of rolling a 5 are also 1 in 6. the chances of spinning our red is 1 in 4. So once we have those fractions identified, we're going to set them up and multiply them. 1/6 times 1/6 times 1/4. I have the 3 different pieces of information. When I multiply all the numerators, 1 times 1 times 1 is still 1. When I multiply by denominators, 4 times 6 times 6 is a total of 144. Finally, there's one more thing we need to look at before we finish. This is assumptions. Your textbook is often going to ask you, what are your assumptions? An assumption is to take something for granted or to believe something will happen based on your past experiences and events. For example, I assume the sun will rise in the east and set in the west tomorrow based on the fact that it's happened every day for my whole life. I assume the highway will be busier on the weekends based on the fact that it has been for the last year. Neither of these are guaranteed, and the events could change the outcomes. So when you are asked to identify what are your assumptions, there are a number of different things you can list. In the question we considered, the probability of spinning red and rolling an even number, I made assumptions. I assumed that the spinner worked correctly, and that each color had an equal chance of being spun. I assumed it was not broken or sticky. I assumed that the die was an ordinary die. I assumed it had not been a trick die or a weighted die.